So 2 weeks ago, I made a video talking about all the things that I wanted to get done by the end of this summer. Well, the first thing on the top of that list was the robotic arm. So 2 weeks into the process, this is what it looks like. And now I want to show you all the steps and things I had to learn and go through to get to this part of the process. Let's see what that looks like. So the first thing in this project that I had to do is what I do with every project. Define the focal point. And the focal point is basically what is everything else going to be surrounded around. Now, for a robotic arm with something a lot of movement, it's actuators. The reason I call the actuators the focal point is everything else surrounding it is going to be affected by what type of actuators I decide to use. For instance, the type of Arduino I use or the type of Arduino shield I use is going to be affected by the type of actuators I use. Another thing is, all the 3D prints that I make and all of my models will be made to fit these specific actuators. So I first have to define what actuators I want to use before I can start doing anything else. When deciding what actuators to use, I had a couple things to keep in mind. First, the actuators needed to have continuous rotation because the arm needed to move more than a 180-degree servo could allow. The second thing was torque. Even though I would be using pretty hefty gear ratios at all the joints, I still needed an actuator with native torque so I could still maintain some speed and have more freedom. And the last and major thing when deciding what actuators to use was cost. Now, my budget on these projects is not that big, so I need something that wasn't going to break my wallet. After thinking about it and doing some research, I landed on a solution that I'm pretty happy with. This is a hobby servo. I decided to go with one of these because they offer a great amount of torque for much cheaper than you can get a motor for the same torque. They also have these perfect little tabs on the sides for screwing things into. There's just one problem. One of the requirements I listed was continuous rotation. For those of you who don't know, servos can only rotate 180 degrees, but a motor can rotate in either direction forever. Well, like I said, these are hobby servos, and the hobby servos can only rotate 180 degrees. But the only reason I picked these is because after doing research, I found it's possible to unlock these hobby servos and make them have continuous rotation. Let me explain what I mean by that. If you open up a hobby servo and look at the main components inside, you'll find something called a potentiometer right here. The potentiometer is directly attached to the main drive shaft of the servo. This potentiometer sends information to the driver board that then tells the servo what position it's at. If we then take a potentiometer like this and cut off the shaft like this and then glue it down so it can't rotate, it will be stuck in place and the servo will be tricked into thinking that it's forever in the same place. If you then go to the top of servo, up here, go to the main drive shaft and remove this pin right here. This pin right here stops the rest of the servo from moving past 180 degrees. If you remove that pin, you will successfully have unlocked a servo. So let me explain how this works. Using a computer like this Arduino, you can send signals to the servo driver board telling it to spin this motor right here. Well, this motor ultimately spins this drive shaft, and this potentiometer that we looked at earlier is directly attached to the drive shaft. And the driver board will keep receiving signals from this computer and spinning the motor until the potentiometer that is directly attached to the drive shaft tells it, hey, I have spun to the required location and you can now stop. So let's say this here is our drive shaft, right? This and this is the drive shaft, okay? So the drive shaft is currently at this location, but the computer is this required location. The computer is sending signals to the servo that we need to go to this location. Well, the potentiometer is hooked up to this drive shaft and is rotated to that position. But as we spin the servo, it goes to the required location, spinning the potentiometer to the location. And once this potentiometer reaches this location, it will cut all power to the motors and stop moving. But if we were to cut off the end of the potentiometer so it is no longer connected to the drive shaft and glue it down, it would never reach the required position. The potentiometer would always point in this direction and it would never get to the required location. And because the servo doesn't reach the required location, the drive shaft keeps spinning and spinning and spinning, thinking that it will eventually reach the required position, even though it never will. So now that we have decided what type of actuators we want to use, I now need to start printing things that these actuators can fit in that will work with the robot. So the first thing I printed was this piece right here. And this piece just allows a motor to slip into it like this, and will keep the drive shaft open and ready for use. And now I can take this design and attach it anywhere I want to. For example, I could place that same exact little design into the bottom of a disc, and now the servo can fit into a disc just like that. The reason I made a servo mount inside of a disc like that is because my original plan was to use something called planetary gears. Now the name for planetary gears is rather fitting because that's exactly what it looks like. This is a planetary gear setup, right? You have your sun gear and then the planet gears around it. I played around with this design for a while, but I soon figured out this was actually a rather unnecessary and complicated solution, and it was just going to become unreasonably hard to do. So I came up with something much simpler. This is a solution I ended up using in the robot. You'll see it's a lot simpler because all I use is a drive gear and a powered gear that help move the rest of the robot. It's a lot simpler and I don't have to use all those complicated gear ratios. And once I had this figured out, it was off to the races. I knew I could add another joint here using these screw holes that I made and just keep building up from there. And I wanted to use a similar design as just powered gear to moved gear over and over again for the rest of it because I knew that worked fine, so that's what I did. And I first decided to build the elbow joint, whereas this is the shoulder joint, I wanted to build the elbow joint next. This is the elbow joint I made. As you can see, I have the servo running in the back here. It's connected to a gear inside there, and it powers this gear that moves this pivot point. I want to talk about that elbow joint in particular because that is actually the second design that I made for the elbow joint. The first design I had was just not working. I didn't like the way it fit together, and a lot of things were wrong with it. It didn't look nice, and everything was just weirdly shaped because I was working towards a goal and I just didn't quite fit it. And so I did something that every maker has to learn how to do. I scrapped it and I started over. Scrapping everything and starting over is a lesson I had to learn the really hard way. Back in 2018, I was getting ready for a robotics competition called Bot Ball. Now, robotics competitions, you build your robots in advance and then you run them once you get to the competition. Well, I had been working on a specific robot for months now, and I knew in the back of my mind that this robot was not going to work. But I had already invested so much time into it that I wasn't willing to let it go yet. And so I just kept sinking more and more time into this terrible design of a robot, hoping that I could eventually get results out of it, but it just wasn't happening. I poured everything into that robot, and it just didn't work in the end. And when I went to that competition, everything fell apart. As you would expect from a crappy design, when we went to the competition, the robot did not perform well and almost failed every time. Back then, I was really confused about why it wasn't working. I thought I had poured so much time into this robot, even though it was a crappy design. I should have been able to come up with a solution and fix it because I worked so hard with it. And it wasn't until months later that I realized it doesn't matter how much time you put into something if it's a crappy design. So I took that lesson to heart, and the next year, when the same thing sort of came up, and I started working on a robot, and I just did not like the overall design of it, I didn't care how far I had gone into the process. I scrapped it, and I started over. And that made me much happier in the end, because we ended up going to a competition with a bot that I was super pleased with. Now, this is not always the case, but I hope you'll heed my warning when I say sometimes, and I mean sometimes, not all the time, but sometimes it's better to just let a design go and start over so you can get a result you're happy with. The reason I say sometimes is because this is not even close to always the case. There are always other solutions where you could technically get it working. I just want to put that out there because I don't want people thinking, oh, there's one screw hole wrong on my design, I need to scrap the whole thing and start over. No, I'm saying when there's something inherently wrong with the basis of the design, sometimes you need to start over. If you're really early into the process, yes, you can alter it. But sometimes, and only a few, but sometimes you do need to start over, and that's okay. So after I made the elbow joint, I quickly whipped up the rotation joint. This rotation joint will connect the elbow and the shoulder together, as well as giving me another axis of movement. So that's going to be it for me. That's the end of episode 1. If you have any suggestions on how to make the bot better, I'd be more than happy to hear them, and I'll come out with episode 2 in the next 2 weeks, so stick around.